Okay. Um, as we're designing things, we really want to think about how the printer works. We have limitations on what we can do, and if you can see the printer print just a little bit, maybe that'll help explain it. Um, okay, I started the printer up and let it run for a little bit, and let me just turn that on, and kind of talk through it a little bit. Okay, so here's the printer. I'm using my cell phone for this, so you'll have to forgive me for being a little bit shaky and not quite pointing at the right things because I'm trying to deal with a couple other stuff at the same time. You'll notice the platform comes up and it starts oozing the filament out of that thing. Now I'm watching the filament, so I'm not watching the camera, so I'm ended up pointing low. It'll point back up in a second here. And I'm trying to keep it. It's also very hot, so you can't like grab it with your fingers. And I didn't want it to drag it over there with the rest of it. So now you can see that it's actually literally painting the plastic on the surface with this nozzle of it's a molten plastic. It's about 190 to 200 degrees C. It draws a ring around the outside to get started, and this is the actual thing it's making. It's a container. We're not going to let it get very far. But you can see that it just continually lays down little piece at a time like this. And the nozzle diameter is 0.4 millimeters. And so every swipe back and forth is really pretty small. When it gets done with this layer, it doesn't layer to shot. So it'll get done with this layer. It'll make you can hear it, but it's not very loud. It just moved that platform down by zero point 0.2 millimeters. So this thing starts taking, if you do very much printing, it takes a long time to print stuff. So that's part of the reason why we want to keep this stuff minimal. The other thing that you want to think about is when you're printing it layer by layer, the issue is going to be how do you print something up in the air? I mean, when I printed this, there's a problem with this. I mean, if this is sitting on the bed, okay, I can do the four flat pieces just fine, and then it comes up and it actually can do these columns just fine. It does the little one on each side, and then it moves up at 0.2. All of a sudden, when you get up to this top layer, how does it do that? I mean, because if I just take this molten plastic and just start stringing it off over the air, it's just going to sag. I mean, it's molten. It's not going to go anywhere. You can't print in midair. So, in this particular case, there's a way of saying you want to build it with what they call supports. And it builds up a whole structure in here that gets broken out later. So that first layer on the top can get in the right place. Once you get a couple of those in there, then it's fine. Then it's got something to print against. So that's kind of how we have to do it. Now, as I said, this took 11 hours. It wouldn't have taken anywhere near that long if it didn't have to build all the supports inside this cube to hold those pieces up on the inside. So you want to kind of keep that in mind, that we can't really print that. And sometimes it's the printing in certain dimensions. Sometimes you can flip something over or put it on its edge and you can print it just fine. You can violate some of these rules if it's not very far. I mean, if it's just sticking out a millimeter, you can actually fake it. And you can print at a slope sticking out about 45 degrees without too much trouble. So, you'll see me print something and it'll actually come out like this to get some width to it. And when you do that, it can when it's building a layer, it can actually ooze the plastic out over the edge, and you can get a 45-degree angle okay. But I mean, when you start, this container, maybe the dock camera is a little better. Let me go back to dock camera. Okay, this container it's a lid in a container, and it's printed separately. You don't print them at the same time; they print next to each other. But it's got threads, and you can see. I don't know. Will it focus? It likes the keyboard better. It's got threads that we actually printed, and they do have a slope, so it can print these. But I mean, the container itself has to print in this orientation. Let's go back to me. The printer actually has to print like this. The bottom's fine. The sides come up just fine. But those threads in there, those are a little trickier. But, if you're careful and stuff, you can actually make that work. And then the lid is printed upside down. So again, the top side is flat against that glass plate. And then it builds everything up from there. And again, that works out pretty well. There are libraries of functions like for threads and that type of stuff that enable you to do this. This is OpenSCAD. And if you want the designs, I can certainly give it to you. I've got it set up where you can just say how big a container you want. I do the same thing with little teeny things. Now let's go flip back. This is about as small as I can make it work. It's full of electronic parts that we use in the 300 level lab. It's not focusing. There we go. Oh. But yeah, so it's the same thing. There are limits, but we'll just work around them. Okay. As I said, it's kind of an effort to change the color in the printer. So what we're going to do is pretty much just stay with the white that I've got right now. When I run out of that, I think I've got a spool of black that's up next. So we'll print with whatever it is. So I'm not too worried about the color. For the artsy people in the class, you know, later on you can actually get colors. And for printing, you've got options. If I print it for you, I don't have any way of charging people, so it's all free. If you go to the Double E shop where you got your little electronics kit, they've got several printers down there, and they do have other colors. So I mean, you can print stuff down there, but they think they charge $1 plus 5 cents a gram. So it's not very expensive, but you know, you can just go for it. Okay. I think I'll stop this video here because we were going to go back and do some more CAD work because I'm now, when I tell you I've got to build something a certain way, then you can understand it. The other thing is that, you know, when the bottom side of whatever we're printing has to be flat against that glass. If it doesn't stick and it comes loose while it's printing, then it breaks everything and then everything quits. So then we have to start over. So, okay. What else do I need? I think that's probably about it for this video.